Okay, so this talk is on ROS and Jupyter. I'm going to be demoing Jupyter Lab here. I'll show you how to start it up, get it running, and a few things you can do with it. If you haven't seen Jupyter Lab, it's very popular with data scientists. They're using it for all the AI stuff. So it's a pretty neat tool. It's basically a web-based IDE. And just recently, like this year, somebody's ported over some ROS libraries, or got ROS to run better on Jupyter Lab. So I'm going to be demoing that. So, okay. First, I'm going to launch it. So I've created a Docker file that contains a lab. And this is just a quick start on launching that. And I've already got a ROS master running in the background, so we don't have to worry about this part. So you just run this command, and I have, once I get the lab up and running, which actually contains the presentation, I have links to all this stuff. So if you're interested in how I'm doing this part of it, you can see that. So I'm going to launch the a web browser to the URL of Jupyter Lab, which of course is opening on the other screen. Move it over here. There we go. Okay, so this is Jupyter Lab. This is running. This is just Chrome. So I got it pointed to a local URL on my laptop. And so inside of Jupyter Lab, it's basically a web-based IDE. So you have all these like file menus and stuff. So this is not part of Chrome. This is actually part of running in the web browser itself. You know, so I have different settings, file menus. I have my workspace that I can navigate to different files I'm working on. If you've seen Jupyter Notebook before, this is like a kind of a newer version of Jupyter Notebook, a branch. It's really strongly based in, well, it's a part of Jupyter Notebook, I actually should say. And it just adds ability to like drag around windows and to have the file manager built in and stuff like that. Okay, so let's see. So I'm going to open the demo file, which is going to show off some of the capabilities. Let's see, demo.
My NVIDIA board uses Jupyter notebooks just like this.
Yeah, it's very popular. So it's kind of cool that they finally somebody got it working on ROS. It's sort of worked on ROS before, but it was a little sloppy. So I'm not going to go over Jupyter Notebook a lot. I want to cover the ROS stuff more, but this is just like a quick intro. So you have different kind of cells in here. So I got my like controls up here. I can like add, remove, and cut these cells. There's two different main types of uses. Markdown. So this allows you to, so I can create like a new cell, and I can change the type to Markdown, and then I can do things like just use Markdown code, like a header. All right, so that just looks like text, but if I hit Shift and Enter, it executes it, and then we see what the Markdown code will look like. So anything you can do. So if you use, it's real popular in GitHub, like GitHub readmes and stuff. So if you want to do like a web link or something, you can, I think, put brackets around it and stuff like that. So. And then, well, actually, I think you have to do parentheses around that. Anyway, so that's a header. And then you can do regular Python code. So I can create a value. I can say A is equal to 1, and B is equal to 2. And then I can do something like print the result of A and B. And then shift enter, and then so I get my output in the cell there. So it gives you a way you can write code and you get like immediate interactive feedback from the code. So it's pretty useful to get that quick of feedback. Yeah, go ahead.
On my NVIDIA, they'll have this, but then there's a whole lot of steps like the import reports, and then it's not going to be 8 plus or 1 plus 2, but stuff like that, a whole bunch of them. And they want you like execute them consecutively, it seems.
Yes.
Is there a way to make the whole page, except for the text, the comment text, to execute and say just run this whole thing?
Yeah, you can run all the cells. I think it's in the run. You can just run run all cells at once.
All right.
So.
Okay.
But it does process it one step at a time.
And,
Yes.
and that's okay. I wanted that, but I
Yeah.
was like, I was doing them individually. I was like, I could do this whole page and don't skip any because it's not going to work.
It probably shows you right. It's gonna be hard with 1 plus 1, but this will turn into a little star, that 1 in that bracket right here, while things are running. We'll see later. I have one that actually takes a while to run, but that one just flashes and executes. Okay, so all right, so you can do your normal imports. You have to have these already installed. So I've already have this Docker container set up with some of these libraries. So ROSB is just the ROS Python library, and so this is not really specific to Jupyter Notebook right now. So what I'm going to show you is just me running normal Python code that happens to be in a web browser. So this is nothing special. I'll get to the interesting stuff later. Actually, I want to clear my outputs. It saves like your outputs from previous times you ran it. So for this, I've already tested it, so I want to clear that out real quick. Okay, so actually I think I need to re-import this because it cleared everything. So I'm importing the ROS library. I'm going to import ROS node, and I'm going to get a list of node names just for demo purposes. So, all right, so this is actually listing the nodes I have running on my laptop right now. So I have a few things running already. I have like, because I have my robot right here, and so I have the laser on and the map and stuff like that. So we can see that we can see a list of all the ROS nodes. And ROS nodes just being little programs that send and receive ROS messages. I can create a new node, so I'm going to create a demo node right here called Jupyter Demo, and then I will print out the list, and we'll see that it should now have Jupyter Demo here, which I didn't have it in the list up here before. So, and you can jump around in notebooks. It's another interesting feature. Like I can rerun this, and now I have Jupyter Demo up here again. So it's a very interesting way of programming for people that have to compile and run everything at once, to be able to just run a couple lines of code and immediately see the output. Okay, so to do for demo purposes, I'm going to launch TurtleSim. So TurtleSim is just a little ROS demo node. Let's see. Yes. Okay, so I'm going to open a new tab, and I got also a Docker container which I created that has TurtleSim running in it. So this gives me a little TurtleSim is just a little graphical program that responds to ROS messages. So I can control this like my robot, so I can kind of test out sending velocity commands, which is really what I want to focus on in this talk, because that's what we're going to be working on the Club Robot, is how to control it and how to send move commands to the robot. Okay, so let me just put this always on top. There we go. Okay. All right, so now that TurtleSim is running, I can get information about the TurtleSim node. Yeah. My mouse is not working very well. Okay. So, all right, so these are the nodes that it's publishing. So we have like a pose, color sensor. I haven't really used that much. And the main thing we're going to be focusing on is the subscription, and this is the command velocity. So by subscribing, it means that this code right here, this turtle, is listening to messages coming from on this topic, the Turtle 1 command velocity topic. It's also got a few services. I'm not going to get into those too much. We will clear it at some point when it gets a little messy, but we'll do that later. Okay, so I'm going to use ROS Python again. I can get a list of published topics, and we can see those because they got the laser running. It's got a lot of topics, but we should have the turtle stuff in here somewhere. Turtle 1 color, and then the command velocity is in there somewhere. Actually, sorry, does not show unsubscribed topics. So this is only topics that have actually been, they're sending data right now. So since the turtle is listening for the command velocity topic, it's not published yet, but it will be soon. Okay, so if I want to move the turtle around the screen, first I'm going to import a ROS topic library, and I'm just going to show some info about the topic first before we actually start moving the turtle around. So I print some topic info. So this is the type of topic. So this is basically, this is a way to look up like what variables the topic holds. So this is a twist topic, and this is a standard topic you would use for moving a robot around. Most types of robots, I think, would respond to this. Even like legged robots would probably translate these commands into some kind of biped motion. Okay, so it's a twist type. I can print out the topic type. So we got geometry messages twist, and then I can get info about this message. Now this, we don't actually need to do this. I just want to show you how you can like get some introspection about the topic. So normally if I was doing this in ROS, I would probably be using the command line, and I would be using ROS topic or ROS node to get this info. But in here we can do it in the browser. So, so this is the basically the variables that the topic contains. So it's got two objects. It's got a linear object and an angular object. Those are of type vector 3 in the geometry messages package. The linear has 3 floating point variables, x, y, and z. So we are going to construct a message of this type using these x, y, and z variables, and that's going to basically be the instructions of where our robot's going to move, or in this case, the turtle's going to move. So yeah, twist message consists of 2 vector 3 messages, each 3 floats, x, y, and z, linear and angular. And then all the values, linear values are in meters per second, and angular values are in radians per second. This is kind of the standard that most people go by. You can't always do that. Like for example, this robot right here, I don't have odometry right now set up in the robot, so there's no way for me to like really tell it, you know, go forward 1 meter per second or 2 meters per second. So what I do in these really small robots, I usually just do 1 is 100% full speed and 0 is like stopped. You know, not really the way things are designed, but it kind of works out pretty well. I've done that with a bunch of different packages and that, and those are reasonable values. Okay, so I'm going to create a publisher. So a publisher is just what I use to be able to send messages to the topic. So I got to import the twist type because that was our topic type. And then I create a publisher that's going to publish on the Turtle 1 command velocity topic. And it's going to use twist messages. And then the queue size is like, if you want subscribers to get old messages, you can have a larger queue. 0 means if I sent you a message and I sent a message earlier and you just now came online, you're not going to get that message. But if I had a queue of 1, you would get like the last message sent, or the last 10 messages sent. For command velocities, you want to be live and up to date, so 0 is the best, I think.
Is it, if you had a 1 in there, is that waiting for acknowledgement to
No, it just saves. It tells the publisher to save, and then when it gets a new subscriber, it says, "Hey, here's my last message." Or if you set that to 100, it can say, "Here's my last 100 messages." But obviously, you don't want to save 100
Right.
movement messages because it would basically replay.
It had to be something you knew was going to be
Yeah.
offline for a while and then come on.
Yeah, but for sensors, it might be useful to have the last sensor reading or something like that. So, everything in ROS is really sending and receiving messages over these topics. So it's sensors, it's actuators, it's every part of your robot. Okay, so I created that publisher. All right, so now to use it, I can create a twist message. So that's all I'm doing right here. I'm creating a brand new twist message. And remember, we had linear and X. And so the different values are, actually should have gone over those real quick here. So X is forward and backwards on the robot. Y is left and right, but this is not a turn, this is a linear left and right. So this is a sliding to the left and sliding to the right. So if you have something like this base, which is omnidirectional, you can use Y. If you don't have an omnidirectional robot, Y doesn't make any sense. So that would just not be used in your case. Z is up and down. So since my robot doesn't fly, we're not going to use that. But if you have a drone, then that would also make sense. Angular is turning. So Z is the main one we're going to use. That is turning along the Z axis. So the Z axis is vertical. So we're talking about spinning around the Z axis. And then you can also spin around the Y or X axis. Again, that's be great for quadcopters and stuff. But for most wheeled robots, you'll only use X linear and Z angular will be the only two variables you have to worry about. Okay. So I'm going to create I create the twist message. I'm going to set the value to 5. So that's 5 meters per second. I don't know what the scale on this simulation is, but that should get it to about the edge. Hit shift and enter and run, and we see the turtle drives forward at 5 meters per second. So you notice it stopped. I didn't tell it to stop. So the turtle stops if there's no message received for 1 second. That behavior varies from robot to robot. So it really depends on how you program your motor controllers and stuff. A lot of robots, you have to constantly send velocity messages. And if they don't get a message, it's kind of like a dead man switch. They'll stop moving. Some are set up to latch on. So whatever the last message is, they will continue. So if that's the case, you set an X to 5, it'll just keep driving forward until it receives a stop command. So you got to understand how your particular robot's set up. Okay, so if I want to negative values, move the robot backwards, so I can publish a reverse, and we'll get the turtle moves back to where it started. So the angular Z is counterclockwise is positive values. So I'm going to give it a little bit of forward momentum, and I'm going to give it some turning rate of 6.2 radians per second. So that gets it to go in a circle. Negative values go the opposite direction, so these are clockwise. Do that. Now I can reuse, I just wanted to demonstrate that we can reuse the twist messages. So I've actually been reusing this, but you can send it more than once. You could also create new messages every time, but.
Why does it stop to the left? Why does it stop there? Is it didn't hit anything?
Yeah, it's just a time thing. It's literally a time thing. So it's just going at 1 second. If it doesn't receive a message, it just stops.
Okay.
Yeah.
Did it only update one part? So you had your the radiant, and you had the speed linear. Did it just you changed one of the variables, but it looked like it still went forward and turned.
Yeah, I set both of them simultaneously.
Right.
So
on 16 you did them both, and then on
Yeah.
17 you did one of them.
yeah, because I already had set Z. So when I set Z again, or I already set X up here, so it didn't change
Right,
between
so
one and
that was
another.
my question.
Yeah.
Retain that variable and set them both again.
Yeah, I could have created a new variable that would have been cleared with all zeros, or I could have reset this to zeros. It's real flexible. It's it's Python code, so it just depends on your use.
Yeah, in this sense, it's global, I guess. So it went
Yeah.
carried on. Yeah.
Most of the time, I do see people they make one object and then they update the variables continuously and keep resending that over and over again. That seems to be the standard, and I guess I'm not.
You don't have to.
I don't have that much detail about like Python and object creation, how expensive it is. So, but typically most programming languages you don't want to create too many. So, okay. And then I just wanted to, this is like just a quick demo of just showing that you can use, now I got standard Python code that I can control my robot. Again, this is just, the turtle is running here, but this could very easily be an actual, I could have this robot, the physical robot, listening to it. It's a little dangerous for that much of a demo. So I'm making a new twist message, and then I'm just doing a simple Python loop. I'm going, just counting to 5 basically. I'm updating the message. I'm publishing the message. I'm sleeping for a little bit because if you don't sleep, it doesn't like remember the previous, or it does sort of remember the previous commands. But basically, it's going. If you send it 50 commands in a row, only really the last one's going to register. So you want to give it a little time to drive, so I'm just giving it a half second to drive. And I got a second like inner loop, and then I'm doing some circling and stuff like that. So just kind of show this running. And also, if you notice when I run this too, if you watch, you can see that you'll see a little asterisk here as shows the code's actually taking some time to execute. But okay, and then it's done.
So that ran off the screen that time, or did it stop? Is that?
Yeah, the turtle bot has a wall here. When it hits a wall, it just bumps up against it.
Oh.
It can't actually leave the screen, so.
No, but it'll hit the wall and just scoot along the wall.
Yeah, it's good. You can see the lines kind of straightened out there at the wall. I guess it's representing a robot in a, yeah.
So how is this program increasing the diameter, how do you make that? Is it because you're increasing the velocity there, the angular velocity?
Yeah, I'm just playing around with the speed. It's all just
Okay.
speed control, so.
Okay.
Because every time through that bottom
Yeah.
loop, I increase.
Yeah, if I,
Right, okay.
so, yeah, down here,
So you're dividing it by 100 by every increasing one.
yeah.
Okay.
It wasn't fancy, it just kind of had an interesting, I just wanted
This is a smaller.
It is
an interesting pattern to draw.
You can generate patterns like that with such a small amount of code.
Yeah. So, I would like maybe later after the demonstration we'll see if we can get the real robot to drive in that pattern, but I haven't actually tried that yet. So, okay. Okay. Yeah, we'll put it on the floor. 5 meter. Wait. I'm gonna say 10 meters squared. Just because I drove 5 meters forward for 1 second at 5 meters a second. I mean, I drove forward for 1 second at 5 meters a second. So
And it returned to the center.
yeah,
Looked like it did at least.
and it made it to about the edge. So that's my guess. But that's just a guess. I'm sure you could look it up, but I don't know. Okay, so now we're into the so that was just standard Python and ROS Python. So that would be like how you would write a node. Like typically I would use like VS Code or something like that to write that kind of node, and then run that on my robot. But now if we want to get some interesting feedback, this is what they've been working on recently, is the Jupyter ROS. So I'm going to import the Jupyter ROS library. I think I'm re-importing twist, but it doesn't really matter. I didn't need to because I had already imported it way up there. Okay, so I can create a new publisher. So I created the ROS Python publisher, but now I'm going to create a Jupyter ROS publisher. It's just interesting. So when I run this, you see now the Jupyter ROS publisher actually gives me this widget. So it uses Python widgets to embed HTML and JavaScript into the Jupyter notebook, and allows me to control the robot directly through this like graphical interface now. So I can give like, so I can set some, I'm gonna set a turn command, and then I can just hit send message, and oh no, oh I did, sorry, I meant to do Angular.
I jumped at it and didn't know.
Yeah, I'm doing the wrong box.
Right out of the screen.
Okay, I was worried it wasn't working. There we go. Okay, so the turtle just moved, and now I can give it, I'll give it a little linear movement, you know, back and forth. What's that? Yes. Yeah, if you want to send, let me slow it down so I'll do a real slow with the turn. So I think we do latch message and send message, and then let me increase the speed. Wait a minute. I can keep sending this. It's not latch message. I think it's off screen here. On the other side of the rate, the resolution to get this presentation to work was a little tight. But yes, you can continuously send messages. So I don't think I'm gonna be able to demo it here because yeah, it doesn't work. No, I don't. I haven't. Oh, yes, I can. Oh, there it is. Okay, I can collapse it. Thanks. Okay, so I can hit this. So now it's continuously sending messages, and then I can just change
On the fly.
on the fly the yeah.
That'd be good if you're doing tuning. Like,
Yeah.
I guess because those variables could be anything, right? It doesn't have to be just travel. You could
Yeah.
use,
So now I got control, and then I can hit, I think this should say stop now. And I can stop sending messages, and the turtle stops moving. Okay. Let's see. Let me move this guy a little bit over. Okay. Yeah, Brett, thanks for pointing that out, because that is helpful. Okay. Okay, since I'm in Jupyter Lab, then I get also features of Jupyter Lab, so I can go and right-click on this guy, and I can go create new view for output. And so now I can actually put these side by side. So I have this like output view over here, and I have my code view on one side, and so I have my, I can run commands on my widget and see the output of Jupyter ROS, which I think is really cool. So you can actually create a whole app out of this that can control your robot. I'm going to show more feedback too from the robot. I'm not going to get into this demo, but they also have some code called Voila. It's like French, however you spell it, Voila. And it actually lets you save a Jupyter notebook in kind of a read-only locked state where you can have all these widgets in place, and then somebody can actually interact with it, so you can write full programs. So this is like very powerful, and you can kind of put it in a container and ship it. Okay, so I'm going to close that out because it's taking up a little too much space.
I don't know.
Put
Are you going
this
to touch on
back.
where the imports come from? Things like that?
I can show the Docker.
Well, I'll tell you why
File.
I'm asking. Is my NVIDIA bot uses the Adafruit motor driver, and therefore it's using Adafruit words for like .run or .forward or whatever they're using.
Mm-hmm.
And so at some point I might want to use a different driver, but currently I'm not sure where I need to put the file that it would look at to use my own command.
Also, after the presentation, I go over some stuff. Probably outside the scope here.
Yeah.
Okay. All right. So we got that. This is a demo of how you can just output a topic. So I'm going to create. This is a real simple function, Python function that just takes in a message and prints it out. And then so I can subscribe to the command velocity. So I hit that, and so now I have this little output. There's nothing interesting in there until I send a message. So if I click send a message, so you see now I get immediate like feedback. So I can like show my variables. It's not as interesting because I'm actually sending the same messages, but if they're coming from the robot, you can actually debug your messages live. So I'll show that. So we got that. Okay. Let's see. This example of how to connect to ROS service. So this is a list of all the services that are available. So this is the turtle's a little messy right now, so I want to clear it out. And so we have this reset service from the turtle. So I'm going to connect to the, create a connection to the reset service and then call reset. And so now we got this is cleared out. So that's the way you can call ROS services. That's more plain ROS Python. I'm going to come back to Jupyter, but I just wanted to, or not Jupyter, but the Jupyter ROS widgets. But I wanted to show some of the built-in Python widgets. So you get all these, like, now that we're combining it with ROS, you no longer get the ROS stuff, but you get just the standard Python stuff. So, like, you can embed HTML. So here's a little, like, HTML thing. You have interactive widgets. So I can create, this is a slider. So this is one of the Python widgets. So I got this slider value goes back and forth. I can use that in my code to live like update values, and I can respond immediately to those values. So I'm going to create a output widget. I'm going to create this is just a method to take the new value from the slider, and I'm just going to print it to my output widget. And then I'm going to observe the slider and then tell it to send all the data to the that method. And then I'm going to show the slider again. So I got the slider twice, but it's actually the same slider because you see I created a new one up here. And then down here I just displayed it again. So I can slide either of these sliders back and forth. They're both synchronized, and I get the output from the slider, which I'm just displaying, but this can be, you know, if you want to tweak parameters of your robot, you can just that quickly make a slider and just go back and forth. I can embed JavaScript. So this is some JavaScript. This is nipple.js, which is just a joystick Java control. We used this for the club robot a while back. So I'm going to execute this. It's a little flaky, but it does work. So it sometimes works. Try it again. There we go. And then so now I have this like JavaScript interactive joystick, and I get a little feedback on the screen. So you can imagine like driving your robot around using this guy. We can use all the tools from robotwebtools.org. So this is all the JavaScript stuff. This is some of their like interactive displays. So this I had a little trouble with, but I have somebody else's demo which I'm going to show afterwards. So I'll show you how far I got, and then I'll show you how it can actually look if you know what you're doing. Okay, so you can create like a 3D viewer. So this is my 3D viewer, and there's not much going on there, but you can see I got this little, I don't know, axe, I guess they call them, in the middle where I can direct things. You can do things like create laser views or grids. It's the, I'm having some trouble with transforms, so I'm just going to go through this kind of quick, and then I'll show you another demo which actually shows what it looks like. So, but I just added a grid to the view, and so you can move that around, and You can put a model of your robot on there if you have like a URDF file, a map, laser, feedback. Essentially, think of this as, I'm hoping, well, it's not quite there, but I'm hoping what this is a replacement for RViz. Basically allowing you to run RViz in your browser and at the same time get like code feedback, which is pretty cool. Okay. That's not doing it. Okay, so you can do, this is an example of getting video feed. So I have MJPEG streamer running on the Raspberry Pi here. Let's see if this actually works. Yep, there it is. So this is a live video feed, you know, from the robot. Everybody out there can see this. Everybody. So we got that.
From the LiDAR. Color LiDAR.
What?
You tell people it's from the LiDAR.
Oh yeah, it's very advanced LiDAR.
Color LiDAR.
So, okay. Okay, so we got that. And then let me show you, so this is a project, I don't know if they pronounce it Zethus or something. It's one of the old gods, the Greek ones, or I don't know which ones they are. So I'm going to show you their project, which they put this together and like packaged it pretty nicely. It's still got a couple bugs, but you know. Okay, so this is now connected to my robot. So this is all running a web browser. This is using Jupyter Python. And so we see we get this is a map of the room. We're not in a very interesting room right now, so it's just square. I'm getting laser feedback from the robot. I'm getting that red arrow is odometry, so as I move the robot around, you know, the laser moves, the odometry moves. There is a bug if you notice, hopefully it'll be fixed soon, but the map does not line up with the LiDAR. So hopefully they'll get that working, but it's still pretty interesting to be able to visualize your robot completely in a browser. I kind of visualize this. I would like to make something just like this, add the video feed on top of it of what the robot sees, add the joystick control, and then you have a telepresence robot where you can see the map, you can see the laser feedback, you can see the video feed. So this is the idea for the club robot and the telepresence feature of the club robot that we're going to want to do.
When I ran my robot, whatever, with the NVIDIA, it was doing the video like what he's shown, and I was using a controller, but it was running the Jupyter deal the whole time.
So, all right. Any questions? What? Oh. This would be right at the plane.
Okay, yeah.
Yeah.
Okay.
Yeah, a little bit of lag, but
Delay.
not too bad. I haven't really used it. I've only barely got this working, but anyway. So, any questions, comments?
Red arrow indicate.
The red arrow is odometry. Let me try to show this a little better.
How is it deciding?
So like that's which way it's pointed.
Right, but, okay, so the direction of the arrow is in front of the robot there.
Yeah.
Except that somehow he showed up back here. So
Or the other way.
Yeah, so if I turn the robot, so now if it's got a good view of the walls now, you can see it clearly. But as I turn the robot, the red arrow is the direction the robot's facing, the laser. Now the map should be moving with, right now that white and gray map should be moving with it. It's a bug that it's static.
Because when you turn it clockwise, is it moving counter? You're turning clockwise and it's moving counterclockwise.
Is it upside down?
I think it's just
hard
upside
to-
down. And that's why.
It's hard to tell. They're having problems
If
with
you're
the
looking down.
transforms. So
What happens if you just turn the whole robot upside down?
Well, yeah, the transformer is upside down. The pieces fall out, I apologize.
But see, now it turns the same way he's turning.
well, I don't know if it's really designed for that, but okay.
I don't know, I mean, but you're definitely on
Okay.
the left side.
So you're
You're behind me.
okay. Hard to say. Okay. So let me point out a couple interesting things about this. So this is them building on Jupyter. So this is actually connecting, even though it's in a web browser, it's connecting to my robot using ROS bridge. So I have just, localhost 90. They have everything set up in JSON. So you can add visualizations and remove visualizations. And then I can show okay, we can hide the laser, hide the map, stuff like that. So, and there's not a lot of visualizations right now. This is a very early project, but it's come along. So,
Promise to it.
okay.